first distribute the negative 2n. So you should have negative 2y minus 8 is less than or equal to, and distribute the 2n as well. So you're going to have 2y is minus 2, like that. Which side did you take the y's on? Did you put them on the left side or the right side?
The right side.
The right side. So you added 2y to both sides. So you get negative 8 is less than or equal to 4y minus 2. And then we add 2. So we get negative 6 is less than or equal to 4y. We divide by 4. So we have negative 6 over 4. That reduces to negative 3 over 2 is less than or equal to y. Now, if you want the y to be on the left-hand side, so the arrow points the way you should shade. If you say negative 3 over 2 is smaller than y, then that means y is bigger than negative 3 over 2, right? So if your teacher, if your teacher was really picky, I'm not picky, you would have to know where negative 3 over 2 is. Okay, so let's think about this. 3 over 2, where should that be? It's 1 and 1/2, right? So it's 1.5. Does that make sense? Because it's 3 over 2 is the same as 1 and 1/2. So 3 over 2, if you were graphing it, it would be like right here. Do you guys see? So you would have everything bigger than that. Now, I don't care about all those tick marks, so I'm fine if you guys do negative 3 over 2 and then do everything that's bigger than it, like that. That's totally fine with me. So our answer should be bracket negative 3 over 2 to infinity. Oops, that's a parenthesis. It doesn't really look like a parenthesis. Okay, are we understanding that? Did everybody get that answer? Good. All right, so this next one, so I have 1/2 x minus 5 is less than negative 3. If I add the 5 over, I get 1/2 x is less than 2. So we've talked about this before. If I had an equation and I said half of some number equals 2, you guys know it. You can do this without doing any operations. Half of what number gives you 2? 4, right? Does that make sense? Half of what number gives you 2? 4. So what we do to both sides to get rid of a 1/2 is we multiply by 2 on both sides. Okay, so I'm going to get x is less than 4, like that. All right, we didn't have to switch our signs or anything because we had a positive number that we were multiplying. So we have an open circle on 4, everything on the left of it. So our answer should be negative infinity to 4 parentheses. Okay, and that's it. Did we get that one too? All right, so let's try these harder ones. So on number 7, we have everything all together. Okay, so it's negative 6 is less than or equal to 2x plus 4, which is less than or equal to 10. Okay, so we could break this apart into 2 separate. So could break into negative 6 is less than or equal to 2x plus 4, and then 2x plus 4 is less than or equal to 10. Do you guys see how I got that? So I took the left 2 together, and then I took the right 2 together. Okay, so you could do that. But really, I don't ever do that unless I had like x's in all 3 like locations or 2 of the locations. Do you guys see? Do you see where the x is? It's only in the middle. So if the x is only in the middle, just keep it all together. But if x is only in the middle, keep the inequality as is. Okay, so as it is. So we're going to keep it as that negative 6 is less than or equal to 2x plus 4 is less than or equal to 10. Has anybody ever done these before? Do you know what this is? Yeah, these ones are weird ones. So this is why we were going to practice this tomorrow, because I was like, I don't know how much of this like compound inequality stuff they've done. So we'll do a couple in the examples and we'll do more tomorrow. All right, so what we do is we try to isolate the x on the inside. So if I was trying to get the x by itself, I have to get rid of that 4, right? So what do? I subtract 4. But I'm going to subtract it from all 3 locations. So I'm going to subtract 4, subtract 4, subtract 4, and then write the new answer. Okay, so now I have negative 10 is less than or equal to 2x, which is less than or equal to 6. Now what? Get the x by itself, so we do what? Yeah. Not subtract 2. What's the sign between? It's multiplication, so we divide by 2, right? So divide by 2, divide by 2, divide by 2. So we have negative 5 is less than or equal to x, which is less than or equal to 6. Oh, 3. Thank you. Oh, Maya gets a bonus point. All right, so now we want to graph that. So the way that this is read is negative 5 is smaller than some number, but that number is smaller than 3. So on a number line, we have negative 5 and we have 3, and we have everything that's in between it. Do you see how x is sandwiched between the two numbers? So our shading is sandwiched between those two numbers. So we're going to have less than or equal to, like that. So negative 5 is less than or equal to x, which is less than or equal to 3. It's going to be the shading in between. So our answer then would be bracket negative 5 to 3. Okay. So what we just did is what we would call an and statement. So when I said we break into these two, this is an invisible and between it. You can see I wrote and. It's like this is true, but also this is true. The two things both have to be true, and it ends up being like overlapping in the middle. But if you have an or statement, they could go in opposite directions. You could have something on the right, something on the left. Colin. So this one is an or statement. So a lot of times the or statements will go in opposite directions. Okay, but not all the time, but a lot of times they will. So let's try this one. So I'm going to subtract the 4, subtract the 4. So I get negative 2x is less than 2. I divide by negative 2. Red flag rule. Right, so we flip that sign. So it's going to be greater than. So I get x is greater than negative 1, like that. Now this other side, I subtract my 8, I get negative 3x is greater than 3. I divide by negative 3, I divide by negative 3. I get x is less than negative 1. I didn't realize I did this. I made them both negative 1, didn't I? So if we have x is bigger than negative 1, or x is less than negative 1, then we have either side of that inequality. Okay, so if I pick a number like 2, 2 works in one of those. It works in this first one, right? If I plug into negative 4 plus 4 is 0, 0 is less than 6, it works. Okay? But if I pick something on this side, like negative 3, negative 3 times negative 3 is 9, 9 plus 8 is 17, 17 is greater than 11. It works there. Right? So every single number works on the number line except for what number? What number is bad? Is there a number I don't have shaded? It's tricky. The only number that's not shaded is right here. It's not shaded, so we have to keep that off. So it's every single number except for negative 1. So the way we write it is negative infinity to negative 1, parentheses, union, negative 1 to infinity. Okay, so it skips over negative 1. Okay, we need to do another one because that was kind of weird. All right, so let's say we have number 9. So you can add number 9 on the end if you have room. If you don't, that's fine. Just put it on blank paper. Or just pay attention. All right, so let's say we have 2x plus 5 is greater than 7. And we have x minus 3 is less than negative 2. Okay, and this has an or between it. So or statements could be two separate sides of the inequality. Like they don't have to be connected together. So if we have this, we subtract our 5 over. So I get 2x is greater than 2. And I divide it out and I get x is greater than 1. But this other one, if I add, dang it, I did it again. Let's make that x plus 3. I subtract the 3 over, get negative 5. So that means x is greater than 1 or x is less than negative 5. So on a number line, what it will look like is we'll have the negative 5, we'll have everything below it, and then we'll have the 1, and we'll have everything above it. And we have two separate pieces. Don't pack up. So we're going to get negative infinity to negative 5, parentheses, union 1 to infinity, like that. So it would be two separate pieces. So we'll do more of the compound ones tomorrow. But